Hello and welcome to Game Revolutions, the series where I work on a Moon Patrol clone game for my TRS-80 color computer. Soon to be a major motion picture starring Ryan Gosling as me. Today we're going to add scoring to our game, and we're going to use binary coded decimal. If you don't know what binary coded decimal is, check out this video that I just did on binary coded decimal. Let's go! Until now, I've been reserving this top portion of the screen for the frame number. And that's just been temporary code to help debug as I've been moving new game elements onto the screen on different frames. This would tell me what frame I'm on. But really, this should be the score. So today, we're going to make this be the score. But there is one aspect of this that I want to retain. And that's the fast-paced increasing that the numbers go through. It feels a bit like a pinball machine where if you get a bunch of points, rather than just binging once and changing the score once, the thing just kind of rolls through a bunch of numbers and it gives you kind of like a dopamine hit of success, like, yes, I did it. So I want to kind of retain that with this game. So if you get a bunch of points, rather than immediately showing you the updated score, it will kind of like roll up to the new score as you go on. And maybe that extra activity will add some excitement. Here's what I've got so far. First, I'm going to have a series of equates that say what different things are worth. For now, I'm just going to add points for shooting the rock. So it'll be 5 points each time you shoot a rock. This decides each time through the game loop how much to increment the score by if the display of the score has not caught up with the actual score. So I've got two values for the score here. What's currently being displayed, that's 2 bytes, but also the actual score that's already been earned, which is 2 bytes. So to implement this pinball style of scoring where it just keeps going up, up, up until it hits the result, this is the thing that keeps going up, 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 and then this is the current limit that it's ascending to. Now these are just straight up bytes. So these are just represented as normal 2-byte numbers. This is to help with the actual displaying. So this will take the score that's displayed and represent it instead as 3 binary coded decimal bytes. If you're not up to speed on binary coded decimal, I'd recommend you watch this video first, as that will clarify a lot of what I'm doing. In the bullet subroutine, we have a bunch of code that does hit detection for the obstacle that's coming its way. And if we've reached this part of the code, then we know that the obstacle is a rock and we have hit it. So the new code is where we grab the number of points we should score for shooting that rock, and then we add that to the points earned. That merely involves loading X with the value of the score earned, adding B to X, and then storing it back again. And as I look at this, I realize this would be faster if I used the ABX instruction, so I should be changing this to ABX. In the main loop, toward the bottom, we now have this update score. Since adding the points earned does not change anything on the screen and just changes that one variable, this is the thing that will actually change what we display, and it will only increment it by that increment amount until it gets up to the amount that was actually earned. We grab what's currently displayed and we compare it with what's been earned. And if there's nothing to catch up, then we just skip and we go down to draw the score. Otherwise, we use this score increment to bring what we're displaying that much closer to what we've actually earned. And we're only doing this once each time through the game loop. On the BCD side of things, we've got 3 bytes. So we add the increment first to the low byte, decimal adjust that, store it back. We grab the middle byte and add the carry bit to it, decimal adjust that and store it back. And then finally we load the high byte, add the carry bit to that, decimal adjust that, and then store it back. And then on the regular 2's complement side, we load the value that's being displayed, we add to that the increment, and we store it back. So now everybody is in sync, and we can go and draw the score. This routine will draw a single BCD byte, so each time through, I load A with the byte I want to draw and I stick it on the stack. Here I'm just reusing that stack space for the byte that I'm drawing each time. Drawing a single byte simply means drawing two nibbles. I grab the high nibble, shift it down, draw it. I restore A with its original value on the stack, grab the low nibble, and draw that. Each time U is pointing to the place on the screen where that nibble needs to be drawn. Drawing a nibble really is simply drawing a single decimal digit. Assuming A already has the nibble I'm drawing in it, B represents the number of bytes per entry of the numeral table, which contains all the bytes that we need to use to stick onto the high-resolution graphics screen to draw a digit. So we multiply the two, and that gives us our index. We grab the table, we index into it, and then we simply draw those 7 bytes. Shoot. I think that worked. Went up to, it goes, ooh. Yes. Yes. Oh, what's going on with the shooting? What's happening with the shooting? Ah, geez, what? I hold it down. Now the shooting is fine. Oh, another bullet came out of a wrong place. What is, oh, geez. Ah, come on. Okay, I think I found it. So add points earned is what we call every time we detect that we have shot a rock. And I'm trashing X, so the caller still needs to use X. So at some point, this X needs to be preserved. I'm going to preserve it actually within this routine. So I'm just going to add a push X here. And then I can combine that with the return there. Okay. All right, that's looking good so far. Nothing seems to be crazy. The score is doing what I like. It kind of makes its way up 5 at a time, but only 1 per frame. No points for that. Okay, I don't think I even made it to that point before. Okay, good. I think we're fixed. I've added some code now to deal with jumping over obstacles, which I've found out is slightly more complicated than awarding points for shooting an obstacle. And the reason is, when you shoot an obstacle, there's a moment in time when you know bullet has made contact with the obstacle, and that's when you award the points. But when you're jumping over an obstacle, when exactly have you cleared it? When exactly have you decided that the points need to be scored? So in the draw obstacle code, I have the hit detection code as before, or I should say the crash detection code. And I'm doing 2 comparisons to see if I should crash the car because it ran into the obstacle. And one of those comparisons tells us that we're actually past the obstacle. We've cleared it. And when that happens, we go here. So at this point, all we know is that we have cleared the obstacle either right now or at some point in the past, but we don't know exactly when. I've added a new field to the obstacle info that says whether we've awarded points for jumping that obstacle yet. If we have, then there's nothing to do. Otherwise, we know we've cleared it and we know we haven't scored it, so it's time to score it now. So I load B with the points you would earn for jumping it. I now have a new site where I call add points earned. I set the jump scored field so I don't score it again, and now I'm done. And FYI, I've decided that jumping an obstacle is worth a bit more than shooting it because you get so many bullets that can go out. It's very simple, but jumping requires better timing, so I just have that worth a bit more. And that goes for whether you're jumping a rock or a hole. So keep in mind, that's worth 5. Shooting is 5. Jumping, ooh, that was 12. That was 7 plus 5 was 12. Okay, good. It gives me 24, 31. Oh, oh. Nice. Nice. And we'll just crash it there. And the score stays at there. Ooh, oh, okay. It's very permissive. All right, that's fine. So the score does not reset. That continues on. All right. This is almost looking like a game. I wish it were always this smooth. It is not always this smooth. All right. Well, looks like we gotta start adding some more challenge into this game. Maybe an enemy. Oops. Maybe an enemy. Maybe I don't need more challenge. An enemy that that moves. That moves around and tries to shoot me. I think that's what we need to do next. As always, thank you for watching.